Hello, this is Mr. Collier, and today we're reviewing linear functions. Now, here are four formulas that are in our MYP e-assessment formula booklet that we're going to be using today. The midpoint formula, which is the midpoint, the point right in the middle of, or right in between two other points. It's called A and B. The midpoint is right in the middle. That's how you find it. It's just the average of the x-coordinates and the y-coordinates. Here's the distance formula, the distance between 2 points. It's called A and B, is given by this formula. And the equation of a straight line, there's two versions here. This is slope-intercept form. The m is the slope, c, or sometimes b, is the y-intercept. And then standard form, which is written like this. You can rearrange it from one form to another. And here's the slope formula. Okay, subtract the y-coordinates in the numerator, subtract the x-coordinates in the denominator. We're going to use all those today. Firstly, the distance formula. Well, you just, and sometimes this could be written as just PQ. PQ means the distance between P and Q. We're just going to use our distance formula. So you got the distance equals, and you can see the distance formula right there, square root, and inside the brackets here, we've got subtraction of the x-coordinates. Doesn't matter which one you use first, because if you reverse them, you get a negative number, and squaring it makes a positive anyway, so it doesn't matter. But I'll do it this way. I'll do 4 minus 0 squared plus, and then 0 minus negative 3. Careful here, you got a subtraction in the formula and a negative 3, so it's like a double negative there, right? Now, what I like to do, because sometimes they'll ask for an exact answer, or sometimes you need an exact number. Okay, because if I type square root into my calculator, I may get a decimal that goes on forever. So I like to do this first. Now I can obviously do 4 minus 0 easily, but you don't need to. You can write in 4 minus 0. So it's very useful if you got more complicated numbers like fractions. You just type it in exactly as you see it there. 0 minus negative 3. Let's square it, and that's everything except for the square root sign. And that's a 25, so you got root 25. So in this case, it is an exact number. If I go click on my calculator now, or if I do square root, I do square root of the answer, click on it, you get exactly 5. Well, sometimes it's a decimal, so this is the exact answer. Well, they're both the exact answer, but sometimes you need this one if your answer comes a decimal. Okay, so it's just the same thing with the next one. You got 2 minus negative 1 squared plus negative 5 minus negative 3 squared. And I'm going to type all that in without the square root sign. 2, yeah, minus negative 1. And then you've got negative 5 minus negative 3 squared. Okay, so you get 13, so that's the exact answer, root 13. Or sometimes you might have a question that says, show that the distance is root 13, so that's useful. You can then click square root of 13. Oops, hang on a second. Sorry, my calculator's a bit glitchy. I will reboot it. Square root of 13. Well, square root of 16 is 4. So I'm guessing this is 3 point something. We'll see what it is now in a second. Square root 13. Okay, so we'll need to do some rounding, and I'm going to round to 3 significant figures. 3.60, so that's 3.61 is 3 significant figures, as you'll have to do in the DP. Okay, these decimals actually go on forever, so we do have to do some rounding. I'm going to also use this approximately equal to sign to show that I rounded. You have to do that on projects and such. What's next? The midpoint of this line segment. Okay, midpoint of line segment AB. So the midpoint formula is in your formula booklet. It looks like this. That's just the average of the x values, because that's how you get number in between two numbers, you get the average, right? And then the average of the y values. So you simply put these numbers in. You got 8 plus 2 over 2 for the x coordinate. For the y coordinate, we've got negative 3 plus 1 over 2. And that gives you 10 divided by 2, 5. And this is negative 2 divided by 2 is negative 1. There you go, that's the midpoint. Okay, find the gradients of these lines. Well, we can actually use the gradient formula if you want to. Which we have, I'll show you there. This is y2 minus y1 over x2 minus x1. Those are just the distances between the y coordinates, and you can get that from the graph. Okay, because the distance between these two y coordinates is positive 2 if I'm going this way with this little arrow. And the distance over here is positive 5. So according to our formula, the slope is 5 or 2 over 5. Sorry. The y's are on the top, and you can put in the coordinates and subtract them just like the formula. But the slope there is 2/5. Okay, and here, now it says 8 there. That's the x-intercept. So it's actually 8, 0. And that's 0, 30 if you want to use the formula from the formula booklet. Actually, let's use the formula from the formula booklet. We can subtract the y values. 30 minus 0. Now I did 30 minus 0, so I used this one. I used 30 in the 31st, right? So now I have to do the same thing. I have to use 0 minus 8. Not 8 minus 0. Okay, and that gives you 30 over negative 8. And just let me demonstrate something on your calculator. Your calculator can simplify fractions for you. I prefer using this little fraction button. We've got 30, and the denominator is negative 8, and you get negative 3.75. It's often better to write these things as fractions, so I'm going to click here. It makes a fraction negative 15 over 4. Fractions are better for slopes because you can see the rise and the run. Okay, if you want to actually graph it, you go down 15, right 4. The decimal is more useful sometimes, like if it's a real life problem and it's like dollars per hour or something like that. Maybe you're losing $3.75 per hour in your business or something. So this is more useful than saying 15 over 4 in some contexts. Okay, we've got this equation here. We can fill in this table of values. I prefer actually some negative numbers, so I would go negative 2, negative 1, 0 for the x values, but they got these values here. And to fill it out, well, you can just do stuff like y equals 3 times 0 plus 2, which is 2. Y equals 3 times 1, we're just substituting in the x value. Alright, but if you've got a HP Prime calculator, you know, you should get used to being efficient. So what we're going to use often is this function app. I can type the function in, 3x plus 2. Alright, and then my table values are just going to be right here under num. Now mine are going up in 0.1s, as you can see. That might happen to you. Just go to shift num. That's usually how you get settings. And that just goes up in 1 if I change this to number step 1, starting at 0. Go back to num now, and that's your table values. So you got 2. Oh, there must be a mistake over here. This is 5. So that's 2, 5, 8, 11. Okay. You may notice these numbers are simply going up by 3. That makes sense because the slope is 3. That means every time your x increases by 1, your y value increases by 3. Plot the points and draw a straight line. So we've got x0, y2. That's the point 0, comma 2. That's the y-intercept. It's right there. 1, 5, 2, 8. Alright, I'm running out of room. I can't do the rest. The next one will be up here, right? So I'll graph that line. Okay, you could probably do a lot straighter if you had a ruler. Okay, next number 7 down here. Find the equation of the line with gradient negative 2 and y-intercept. Well, the equation of a line is y equals mx plus b, or c as it is in our formula booklet. And that's just these two numbers. negative 2x plus 3. Okay, we got a gradient. Find the gradient and y-intercept. This line, oh, notice it's not in the format y equals mx plus c. So we have to make that happen to see the m and the c. So y needs to come to the other side. So we add 3y to both sides, and we have 3y plus x equals 1. Okay. I will subtract x from both sides. And you get negative x plus 1. And we need simply y, not 3y. So that means to divide by 3. Now you get to divide everything by 3. Okay, now this is negative x over 3. That's like a negative 1 there. That's negative 1/3 x, and this is 1/3. So this is the equation. And always reflect on the question and see if you have actually answered it. It says find the gradient and the y-intercept, so I'm just going to clearly write gradient equals negative 1/3, and the y-intercept is 1/3. Next, we got number 9 here. Find the equation of the line. Okay. So the line is y equals mx plus c. We have the m. 2/3. That is a point. We can sub it in. Okay, because this equation is supposed to work for all points on the line, every single one of them. So sub it in. There's the y. That's the y. 4. Okay. And we can use our calculator to help us out. Actually, let me write it like this. C equals. No, let me do that. Let me actually just work it out. That's right. Escape 2/3 times negative 3. So that's negative 2, and you got 4 equals negative 2 plus c, so we can add 2 to both sides, and we get 6 equals c. The question says find the equation, so you got to write y equals 2/3 x plus 6. And that's the answer, which I like to put in a big box around. Now, next, we're talking about parallel lines. So given that find t, given that the line joining this point and this point, and there's a t, is parallel to the line with gradient 2/3. So if lines are parallel, the slope is going to be 3 over 5, 3/5. They're both the same. Now if your slopes are perpendicular, you're going to see some of this in your homework. Then it's a negative reciprocal. Okay? Negative reciprocal means flip the fraction and it becomes the opposite sign. Positive becomes negative, or negative becomes positive. So that means your equation is going to be, well, actually, let's just use the slope formula. The slope formula is slope equals y2 minus y1 over x2 minus x1. Now we know the slope is negative 5. Oh, I picked the wrong one. Not this one. This the parallel one's right there. The slope is 3/5. That's the m. y2 and y1, well, they're there. Look, 4 minus t. And this is 3 minus 1. Now there's a lot of math that you can do here. You can well, you can subtract them, and then you can multiply, and then you can do a lot of algebraic steps. You can also simply solve this by graphing in your function app. It's so useful. So you can graph 3/5, and you can graph, now I'm going to graph this big fraction, so I'm going to click on the fraction button. Then you do 4 minus x, denominator, well, 3 minus 1 is 2, but let me just put it in. There you go, there's your two functions. Okay, so if I graph that now, so the blue line looks like it's right at 3/5, and the red line must be this here, and we can actually find the point of intersection by going to menu, function, intersection, and that is, I'm going to draw a sketch. The point of intersection is 2.8, okay, comma 0.6. 0.6 is 3/5, by the way. Okay, so 2.8 is your answer. 2.8 is the x value where these lines meet, and x in this context is just t. So t equals 2.8. Okay. Yeah, and that's it.